Habt ihr alle die neueste Version runtergeladen? Hast du?
Wohl teilweise, glaube ich. Wir würden mal nachfragen, die heute rausgekommen ist.
Guten Morgen.
Wisst ihr da Bescheid, wie auf die Webseite? Oder soll man das kurz ansagen?
Oh, was ist das?
Die von gestern geht nicht, oder?
Doch, geht auch.
Das habt ihr jetzt Ubuntu von einem Stick gebootet.
Auf der Webseite, wenn ihr auf den Blog geht, gibt es diesen Blog-Eintrag. Und da in diesem Blog-Eintrag gibt es die neueste Version. Ich habe die gerade selber nochmal installiert. Gestartet. So sollte das ausschauen, wenn ihr startet. Sind wir schon Englisch oder?
Ja,
Yeah, in English. Yes. Okay, sorry again for the delay, but we cut right to the chase. vvvv Gamma, the new thing we've been working on for only 6 years or something. And finally, we have this chance. Thanks for Chris for this invitation to show this for the first time in a public scenario.
It is actually the first workshop.
The first public one. We had one slightly like at a festival. We showed one. But anyway, so I'm assuming for this workshop that you're all familiar with vvvv beta in a way. And so I will use some slang, some vvvv slang. If I say spread, you know it, what I'm talking about. Things like that. Basically, the idea with vvvv Gamma was about 6 years ago when we started. We wanted to improve vvvv, keep the good things, remove the bad things, and add a lot of new features. And we knew we could only do this by starting from scratch. There was no way really to do this by just incrementally improving the software. So we knew we had to start from scratch. And this is the first official preview with what we came up with. There is a lot of things to say, obviously, about the software, but I think what we do is we're just starting working on a little patch, and along the lines we'll figure out the things that we need. So this is the startup patch, which we don't need. I'm now first going to show you what we're working on. This is the patch we're now going to build together. And what it does is this. I can draw strokes in the renderer, and they are being recorded and filled, and then they kind of are getting smaller, and when they're small enough, then they are gone again. So if you think about what this means and think about how you would do this in vvvv as you know it, it's a bit tricky because of this general idea of having some dynamic objects appearing at some time and then at some later time being destroyed, removed. And this was always something that was rather hard to achieve in vvvv. I will now talk you through how we do this in vvvv Gamma. For this, I'm going to open a new patch by pressing Ctrl-N. for new patch. It should look something like this for you. An empty patch. And I forgot actually to close the other document. So I will close this so the renderer disappears. Right. So we're starting with an empty document. Just a minute, text file here from starts. We're starting from this empty document, and right away, like it was in vvvv as you know it, you can double click to bring up the node browser. So without any configuration needs or anything, you just double click and get the node browser. But you notice it looks different. You notice it shows you a category view. Ist vielleicht doch drinnen? Ne, dann habe ich vergessen, ich muss es nochmal kopieren. Sorry. I want to get my notes over.
You have a Windows Dark theme?
Yes. Where was that?
It's official now. You can just update Windows and then you can have it.
Really?
So it's the same as Apple did.
Yeah.
Oh, nice. So they all go black now. Everybody goes
Just
black.
a Windows update and then you can switch. Right.
So, the node browser, it looks a bit different because it shows you immediately, it shows you a category view. This is all the nodes that are available in the system, but sorted by categories, and you can browse these categories. You can click on 2D, for example, then you see all the 2D nodes. You want to get back out of this category, you remove this tag here by clicking the X. You can go in another category and browse the nodes. There are even cascaded categories, so animation, frame-based, and these are the nodes that are available there. So this is just for you to understand how you can explore the node library. But also, what you can still do is just, if you know the name of a node, you can still type it, of course. And usually the first node we need is a renderer. So let's see. When we type renderer, we should see this node coming up. It's called renderer.
If you don't have it, you probably don't have the latest version.
Yes.
That's super easy anyway, so if you don't have it...
Does anyone not have it?
Yeah.
Can you maybe just go to the people who don't have it and we
No,
continue?
just show how to
No, I don't want to
install
show it now.
the
I don't want to show
sphere
it.
patch.
Don't want to
But
show
it's many people.
Yeah, but
It's too many.
I will show it later. Huh? Can you just go around?
So, hold up your hands when you don't have the renderer node.
Just. Okay.
So it's,
I would
it's
like to
super
not
easy,
interrupt. So whenever someone has a question, Fabian can go around and
Yeah,
solve them.
Yes.
So we have the renderer, and you see the renderer shows up here.
And then click on-
Just to show you, it's very similar to the one we were used to. It has a pin called color, and we can go there and change the color of the background. So this is just as we were used to. The next thing, we want to draw something in the renderer. What would it be? A rectangle. So let's call type rectangle, and what shows up is a lot of rectangle nodes, but the first one is the one called rectangle graphics Kiel, and that's the one.
The first or the second?
It's the second in my, yeah.
What does the first mean like these? Is it important?
Not now.
Okay.
We just choose the one with the little node symbol to the left. So we click that, and now what happens is also something we haven't seen before. This is new to vvvv gamma. Some nodes, not all of them, some nodes ask you a second question. Before they can be created, they are asking you a second question. And the question here is, the system has multiple nodes called rectangle, but they have different input nodes. So the question is now, which input node do you want your rectangle to have? These are all the options you have, and depending on what you choose here, you get a slightly different node. It's the same node, but just different inputs, okay? So that's the idea behind this second question. And to continue our patch here, what we are choosing is the one with the position input. So we're clicking position. And now we see when we hover the inputs, we got the right node, the one with the position input. We take the output, connect it, and immediately we see the result. Now, if you remember from vvvv, there was always the possibility on a rectangle, or it was called quad in vvvv, there would be a pin called color, again, to change the color of the rectangle. This is missing here. This is because the concept in vvvv gamma is a bit different in this respect. You see there is a paint input. And the thing is that all properties of drawing primitives are kind of handled by the paint. Think of it like a material, roughly a material in a 3D programming environment. So what we want is to define a paint that defines the color. There are many paint nodes, but the quickest way to just define a color is a node that is called fill. If we create that and connect it to the input, we see the fill node has a color input. And we can just change the color there. Yeah. So the next thing I would like to do is probably make the quad a bit smaller. We see it has an input called size. And this size is a vector because we can change the size in both x and y dimensions, width and height. And so in order to change these, I right-click on the input. When doing so, this vector editor pops up, and I can change both values individually here, or I can use the upper little number box and change both values at the same time. So I'm just making it a bit smaller here.
Yes, please.
So I have a smaller quad now. The next thing I would like to do is to attach the rectangle to the mouse, so that when I move the mouse, the rectangle moves, okay? So for this we are using a mouse state node. It's called mouse state. And the mouse state has a position output. And I can connect the position output to the position input of the rectangle. But now, as I move the mouse over the renderer, nothing is happening yet. This is different in vvvv. You would expect this to immediately work. Unfortunately, this is a bit like we need one more node now to get this working, which has other advantages, but at the moment it looks like, we need one more node. But in the end, you will see it's more flexible like that. And this node is called the console. So we create the console, and let's see where the mouse device's input connects to, and we see the mouse output of the controller lights up. So this is obviously the one where we can connect it, and still nothing is happening, because the idea of the console is that it needs to be connected to the renderer so that it knows which renderer it gives you the information from. So if you have multiple renderers, the controller gives you the input, like keyboard and mouse, from the right renderer. In order to connect the console to the renderer, you see that there is only one way to connect, but we know what to do in this case. We need a node called group, right? To connect multiple things to the layer input. And this is also a new thing in Gamma, that you can just double-click a link to insert a node. So I'm typing group here, and again, look out for the right node. It's called group skier. You select it, and it's immediately inserted. And now I'm just connecting the console here and the rectangle here. And now, as I move the mouse over the renderer, the rectangle moves along. Right. So we could say this, like, first milestone achieved. We have a little rect moving with the mouse, interactive sketch already. Now you could think that the next step would be, oh, I want to save my work, and just to be able to retrieve it if something happens, or tomorrow. So in beta, as you pressed save after you had a new patch, what happened is that you were asked where to save. And especially in workshop situations like this, it was always like, where would I save this now? So we changed that. When you press save, which is Control S or in the menu, the document is saved and you don't have to think about it. So you would ask, where is it saved? And the answer is, if you go to the quad menu here, you see there is a menu entry called Recent Sketches. And here you can say, show in Explorer, but also you see that this recent sketch that you just saved is already showing up here. So if you go to show in Explorer, then you see that we just created a directory for you conveniently in your user documents for sketches, and this just collects all your sketches, and you don't have to think about it when it's just distracting to think about where you would save your thing. So this is just a way to make a quicker workflow for sketching. So we have saved it, and now another super basic thing. We wanna create a subpatch. How would that work? Again, we had a new idea of how we create subpatches. Instead of in vvvv beta, you would now Control P maybe to create a new patch, and then again you would be asked where to save that patch, and then you would be able to create a node of that patch in the other, in your original patch. So we thought this should be easier, because the thinking is now we need a node here. Basically here we want to place a node, and that's more the action we want to do. So we just double click and say the node should be called my animation, and then I just press node, which is an option that shows up in the node browser. And you see we have a node created that is empty for now. And now the question is, how can we get to the content? And there are two ways. One way is right-click to get the context menu and press open. But this is already 2 clicks, and there is a shorter one if you middle-click it. Like, think of it in the browser. When when you have a link and you middle click the link, a new tab opens, and this is what happens here. We have this patch now open in a new tab. Now we can patch in here, and let's say our animation is just an LFO, just to demonstrate how this would look. So we have an LFO that's spitting out values. Another question is, we have a subpatch and we want to create an output of this subpatch so that we have an output here, right? And the quicker way to do this is we just start a link on the output and press Control while we click. And immediately we have an output. And we go back to this patch. And if you have a mouse like me with these side buttons, you will quickly learn that you can use them to navigate. Again, like in the browser, you can back and forth navigate.
Control click doesn't work.
So if control click doesn't work, I'm just showing you for completeness, the other option is you can start the link and double click. You can simply double click while you have the link active and then choose the output. That's the same. So now that we have the output here, I'm going back.
Sorry, is there a shortcut to navigate without those fancy mouses?
Yes. First, you can use these up here, or there is also a keyboard shortcut, which is the Control and then the less and greater than and smaller than. Yeah. So I have my animation created, and you see it's running. I get my animation out here, and I want to use this now to just rotate the rectangle, okay? But the rectangle obviously doesn't have a rotation input, so what we remember from vvvv, we need a transform node, okay? So let's create a transform node, and you see there are a lot of transform nodes. I'm telling you, we need the transform SRT, which stands for transform, scale, rotate, translate. So it's one node that can do all of it. I'm selecting it. I'm getting a second question. And here the question is not about the input pins as it was before. Here the question is, there is a node called transform SRT, but the same node with the same name exists in different categories. That's why I need to now be more specific. And I'm telling you, in this case, we need the Skia transform, because I forgot to say, Skia is the name of the rendering engine that is used to draw the thing in the renderer. That's just the name of the engine. So we're choosing this, we're getting this node. And now, as you...
Quick question, why can't it be generic? So a generic transform for matrix operation for everything, like Skia or anything else?
Yes.
There
is a normal transform node also, but let's have a look. The output of this is a layer, and that's unusual, so to say, but it's very useful. That's why we decided, in this case, to provide this option, because what it means is that instead of providing a transformation, we insert that into the layer graph. So we're taking the rectangle output and pipe it through the transform. And what that means is that everything that is coming above is transformed. And then, like this, you can also build hierarchies of transformation. But here I'm just using this to now connect this to my animation. And what's happening is not exactly what I expected. Does someone see why this is? I was expecting to just have the rectangle.
It's the center of the whole renderer.
Yes. So what's happening is that I'm changing the position. By changing the position of the rectangle, I'm basically changing its pivot point, so to say, and then it rotates around that. So I'm getting rid of that input, and instead I'm taking the position and connect it to the translation input of the transform node. Because like now I have this other transform behavior.
Is there any quick way to like right click or to delete connections?
A middle click.
Middle click.
Yeah. And whenever I say middle click, the alternative, if you don't have a middle click and still want a quick shortcut, it's you press Alt, the Alt key, and just left click. It's always the alternative.
Is there like a comment box so that we can do some?
Yes, if you just, it's like in vvvv, you just start typing here, and as long as this is not a valid node name and you press enter, it shows up as a comment. So, we learned how to use the mouse to move something on the screen. We learned how to create a subhatch. Okay? I think the next thing is to, if you remember the example I showed you before, we want to record what we are drawing. We want to record each stroke. And I'm sure you've done this in vvvv before. There is this very convenient Q node. And again, be careful, there are two Qs showing up, but we need the one which is a node. The other one is not interesting for now. Okay. But this Q node works just as we know it. It takes the input, it takes an insert bool, true or false. So we say whenever as long as the left mouse button is pressed, we insert. And you should see if I now press the left mouse button, and then on the output I see there is already 123 vectors now recorded. So the next thing is I would expect to be able to connect this output somewhere to the rectangle or to the transform. But none of the inputs light up. Okay? And here we stop a moment and understand that this is the single biggest difference to vvvv beta. In vvvv beta, any node, almost any node, would just be able to cope with a spread, right? You have a plus node, give it a spread or a single value, it doesn't care. In vvvv gamma, this is different. We call this feature in beta, we call it like a spreading, automatic spreading of nodes. And this feature just doesn't exist here. Instead, we have a much better feature, which is called loops. This is what everyone knows from programming. There is repeat loops, while loops, different kinds of loops. And using a loop to achieve the same result is at first a bit more complicated. So we have to do a few more clicks, and it will look a bit more complicated for the simple case. But I will soon show you a more complex case that I hope will convince you that the idea of the loop is the smarter one. And for future cases, it doesn't rule out that we wouldn't still add a spreading feature. But for now, we've decided it's more important to have the loop, which is more flexible overall than this very specific spreading feature. So I'm now showing you how to use a loop. If you double click and type loop in the browser, you see a few things are showing up. The usual suspects at the top, but then at the bottom there are 3 loops showing up. And most interesting for us are the 2 bottom ones, the for each loop and the repeat loop. In this case, we want to use a for each loop. I'm just pressing it, and for each region shows up. The for each region works in a way that here we have an output with 123 slices. And what we want to do is, for each of those slices, we want to draw a rectangle. Okay? That's the thinking behind it. Whenever you have a spread of slices and you want to do something for each of them, you use the for each region. So I'm taking the output, and you notice as I click the output, as I start the link, something happens to the for each loop. It gets 2 bars there. We call the upper option the splicer bar and the lower the accumulator bar. So these are the little symbols, the splicer and the accumulator. We'll come to what means what. We are just choosing the splicer for now, so I'm clicking in the upper bar. What happens is we inserted this link and we can now continue, but we don't need to continue for now, so we just cancel the link with the right click. But what we can already see is if we hover the splicer symbol, you see it looks a bit like a funnel, right? So it means when you hover it on top, it shows you in the tooltip there is 123, the full spread. But if you hover it at the bottom, you see it's only showing us one value, okay? What this means is that as long as you're inside of the loop, you only have to think about one item. This is very helpful. You don't have to think in bin sizes and how slices relate to each other. Inside of the loop, it's very clean. Only one item at a time. This is very helpful as you get to more complex scenarios. So what we want to do for this vector, for this one vector, we want to draw one rectangle, right? So basically, we want to do this for one vector. So, yeah. Except the fill. I'm leaving the fill out. We just want to take a rectangle and transform it. So what I'm doing is I'm selecting these 2 nodes, and in order to move them inside of the region, I press the space bar. And you see it snaps into the region. And inside I can just release. And now the rectangle and the transform are inside of the region. Next,
Did everyone get this? Yep. I can show.
Is there like a way to move for each loop without just grabbing the small for each?
No, you have to grab it here. Yeah.
So I always have to scroll there to.
Yes. Yeah. Now, again, let's come to the vector, the one position that comes in here for the rectangle. We take it and just connect it to the transform, right? To the transform translation input. And then we want to get out of the region because we want to connect this again somewhere here, right? To the layer group. But we can't connect it right now. We first need to decide how do we exit the for each region. And again, we have those 2 options, accumulator or splicer. And again, we're choosing the splicer, which means it now will collect all the elements and return us a spread again. Okay, so I'm choosing the lower option here. And on the output you see it's now again a spread of 123 elements. But still I cannot connect it here because the input, as you see, is only accepting one layer. but we have now a spread of many layers. So in order to get from many layers to one, there is again a special group node, and we can just double click while we had the link at the cursor, type group, and you notice there is a second group called spectra. And this one is just collapsing us the spread of layers to one layer. So we take this, and now we can connect to the layer, and immediately you see the result. The stroke I recorded earlier is now visible.
And the group input is glowing.
And the group input is glowing, and when you hover it with the mouse, actually it should show a tooltip, which it doesn't do for me.
Yes, this is heading showing tooltip.
Yeah, you need that.
Doesn't show.
Yeah. Okay, there should be a tooltip telling you this is a warning, which we can ignore for now. It's just a warning, but it's not interfering with our patch now. What was the next step?
One question.
Yeah.
They all share the animation LFO now.
Yes.
The same rotation. If I put the animation
fill.
inside for each, they get instant, or the animation gets instant? Or?
Yeah.
Okay.
Yeah. So but let's say we want it like this. The color is the same for all of them. If I want a different color for all of them, then I would put the fill inside and could do something. Okay, but so this looks more complicated and was more complicated to create, right? But we have the same result as we were used to before, when we just connect the spread to the transform in mid-word. Okay? We had to use this for each region for now. Let's just accept this for now. The next step was that we wanna this one, no? Oder jetzt so I want to give you now the promised demonstration of why loops in general are very useful, and they allow you to do very complex things very quickly. And for this, I'm showing you a different way how you can create a loop region, is by just selecting whatever you want to have in the loop. So I'm selecting the whole thing, and then I press right click to get the context menu and say surround, and then I choose, in this case it offers me some options, and I'm choosing the repeat loop. What happens is the program is gone. It's gone because the repeat loop says 0 iterations. So what I'm doing now is I'm setting this to 2, careful, because what happens is the whole program is now running twice. And you can imagine what happens if you set it to 100. But this should demonstrate the power of the loops. But in vvvv, if you wanted to do something like this, you would now have to think a lot about how things relate to each other. And you couldn't even do that, because the renderer wouldn't be spreadable like this. Or
Yeah, it would have 2 nodes.
yeah. And here you notice you don't have to think about anything. It's all handled for you, and they are all running independently.
And it's also interesting, if you now put 3, the first 2 still keep their state. So
Yeah.
the first 2 are still running, and you get a third one, which is new.
So it's just adding but not interfering with the others.
Could you give
maybe a more concrete example where you could use this when working on an interaction project? Because it's quite abstract, so we did patch something we would usually patch.
You wouldn't do that. You wouldn't do it like that.
Yeah.
I was hoping it illustrates.
Oh, it does, but like a more concrete example.
That's like every multi-screen installation run by one machine.
Actually, the very last demonstration I will do tonight in the Senko 3D, the very last demonstration will use exactly this feature to show how powerful this is. And the point here is that that whatever you have, you can just put it in a loop and use it multiple times, whatever it is.
In
Just
beta,
one.
you will always start thinking about bin sizes now and spreads, and like you have different things to align to each other. This is what it takes from you. But yeah.
So we could also just leave out the renderer and just surround
Yes.
the console, the mouse state, and all that and then repeat it many times. Use another group spectral and then connect it.
Yeah.
By the way, Twitch is going through the roof. We have 19 with viewers.
19. Amazing.
We're online. 19,000, yeah. That's it. But will it be available after as a video? Okay.
So I just undo this because this was just a little intermezzo to show you. But actually, how
do you undo Control Z?
Yeah. If we remember the initial program I showed you, now what we can do is we're recording whatever I do, but it's like the information that these have been individual strokes is gone, right? All the strokes are in one spread, collected in one spread. So actually, what I want is I want a spread of strokes. Right? I want to keep this structure, this information that the first stroke was already a spread of points. So I have this spread of points, and now I make another spread of points. And by this, I have a spread of points. Okay? Again, something that was not possible in vvvv easily. You would have again thought about bin sizes, and you would be able to do it somehow, but you would always have to remember the structure yourself. And here we now have a way to actually cascade data types, like we can make a spread of points easily. The way we do this is we say whenever the mouse is released, we want to capture what we have, the last stroke we made, and we want to put it in a spread. Right? For this, we're using a node called add. When I press select add, then I'm asked another question, in which category, and I want to use the spread category because I want to add to a spread. And what do I want to add? I want to add the currently queued up points. So this is the item that I want to add to the spread. And when do I want to do this? I only want to add when the mouse button is released. Right? So remember, for these kind of things, we're using the tog edge node. So I'm saying when the left mouse button goes up, is released. So it's the down edge when it goes back to 0. Then I want to do this. And I repeat what I just said. I'm saying I want to only add the spread if the mouse button is released. And this if is the important information here, because that's the language feature that we were always missing also in vvvv, is we didn't have loops and we didn't have proper ifs. So again, I'm showing you the if region here. It's the first one that shows up. It's again just a region called if. It has an input that says a condition. It's just a bool, so it's true or false. And our condition is if the mouse is released, so that's this one. We're connecting this. And now again, so if this condition is met, then we want to execute what's happening inside. So we want to get this add node into the region, and you remember that was by pressing spacebar while you move it and it snaps in. Oh.
There is this other feature that you can like just add an what is it? When you do right click and then you go configure and you can say show apply.
Yes, I will mention that in a minute.
Yeah. Okay.
But first, so this add node doesn't do much yet, because the question is where would it add the items to, right? We need to somehow capture the state of the spread, and for this in the gamma we need something called pads. Pads are visual elements in a patch that allow us to save values, to store values. I'm creating such a pad by typing pad, enter, and now I can give it a name, and I'm calling this pad strokes, because in this pad I want to store all the strokes I will be drawing. This is just the name I'm choosing, right? The name of the variable. So here in this little pad, I want to store all my collected strokes. So I'm taking this up here actually, and I'm saying I want to connect this to the add node, so the add node knows where it would add the items to. So I'm taking this and making a connection to the add node. And now when you make a connection, you notice I can directly connect here, but also there is this bar that showed up as it did with the for each loop. When I started a link, the bar showed up, and again here is a bar. So in this case, actually it doesn't matter, but I'm choosing to enter the if region via this bar, and then only connect to the add input. Just because it looks better. It looks more consistent, because on the output I have no chance. I have to use the output pad here. And now you see I'm out of the if region again, and now what I want to do is I want to again write whatever comes from upstream. I want to write it back into the pad with the same name. So I'm double clicking, and you see the strokes pad is showing up as an option now in the node browser. And this is a very classic pattern that you will encounter very often. It's you define a pad that's called strokes in this case, and you read from it, you use it to add something to it, and then you write that back into the pad. So these two pads here form a kind of a loop. At the beginning of the frame, the information is taken, what is currently in there. Then if the mouse is released, something is added. and at the end of the frame, the information is stored, so that again in the next frame, it can be read from this location. So it's a memory location, right? And you see, if you hover the strokes, you see it's still empty. It has 0 in brackets, so it's an empty spread. But you already see in the tooltip it says spread of vector. And remember, that's just what I said earlier. That's what we want to achieve. We want to have a spread of points. So now, as I make another stroke here, you see that suddenly there is one item in the spread of spread. And this one item has 260 points. So that's the length of the stroke I just made. If I make another stroke, you see it now has 2 items. Right? The first number in the brackets tells us the count of the outer spread. There is a spread of a spread. Let's try to visualize that by visualizing that in an output box. I'm starting a link here and middle click, and I get this I/O box, which shows us there are 2 items at the moment. The first item has 260 values. The second item has 301. If I make another stroke, I have another item in here. And these little things are the scroll bars, so you can actually view all the values if you like. But you might need to size the box a bit so that the scroll bars go actually in the free area here so that you can touch them. Okay, so this should give us an understanding how the data is now stored
it
there.
just works twice, right? So if I would put another pad there, like somewhere else, is that possible?
Yes, you can read from as many pads as you like in one frame, but you can always only store data in one.
I can't move the scroll bars.
Yes, that's what you can't move them if it's like that. First you have, it's a bug. Okay, so removing this, this was just to give you an idea.
Spreadable I/O boxes.
Yeah. So now, anyway, what we have the strokes collected, and we have the information captured that they are individual strokes. That's what was important to us. And now, again, we want to draw them, because here we are still just drawing the whole cube. So this actually, whenever we start a new stroke, we should empty the cube first, right? So we clear the cube whenever we start a new stroke. But you see so the display is now always cleared, but we're still capturing all the strokes. Only now we need to draw them all. Right? So over here, we're now only drawing the current, the latest stroke, because that's the one that's captured in the queue. But here, on this side, we are actually capturing all the strokes we've made before. So now we want to create a little patch where we can draw them all. And for this, I'm using, again, the thinking is, I have a spread of strokes, I have a spread of strokes, right? And a stroke is a spread of vectors. Right? I have a spread of strokes. And for each stroke I want to draw the shape. Okay? So what I do is, again, I'm using a for each loop. I'm starting the link from the stored strokes, and again I'm using the splicer to get into the for each loop, because now for each of the strokes I want to draw the shape, and to draw a filled shape from points there is a node called polygon, and you see I just have it connected here. I can take the output, which is a layer again, go out via the splicer, and remember here now I have a spread of layers, right? So I'm double clicking to create the group spectral node again. So now I have all the shapes as one layer, and then I can add them to the group. And remember to add pins to input to nodes like the group or the plus. You press Control plus. Oh no, that's not to remember. From
no, it's first time.
Yeah, first time. Sorry, forgot about it. In the beta, you would have to open the inspector, change the count. Here, just go there, Control plus, Control minus to add and remove pins. Now we have a new pin, and we can connect the group there, and immediately you see all the shapes that I've drawn before already. They are now drawn.
Is there any trick to force clear a pet if it has some information inside?
Yeah.
Is there some shortcut I can
No,
kill anything?
not a shortcut. I mean, yes, okay. Yeah. So, to generally clear the whole program, you can restart it.
Everything you have.
But that would be nice to have like control, click, pet, and kill anything inside.
Well,
Just
so
for debugging.
yeah, I'm showing you the way we would do it programmatically. To clear the whole spread is we're using a clear node. And we insert the clear node here by double clicking the upper area, choose the clear spread again, and immediately you see the spread is empty. Right? Because now every frame the clear node is applied, and so the spread is always empty. What could I do now to prevent this from being called every frame and only, yes, I could use an if region to only execute this node if something happens. But there is a shortcut that you mentioned before. If I have only one node that I want to conditionally call, what I can do is right click, configure, and say show apply. And this is an input pin called apply that I can now directly connect to, let's say, the right mouse button. So I draw some shapes, and when I press the right mouse button, the clear is applied and it's clearing the spread. everything clear so far? I don't get any reaction.
It's fine.
That's fine. That's the normal.
Welcome to Kiel.
Yeah. Okay.
How it works here.
I can handle it. Okay. So, so far, it was easy because we just had one property of the stroke, and the one property of the stroke was its points. Okay. But what if we now want to add a second property? So for each stroke, we want to add a color. Each stroke would have its own color. So again, if we would have come this far in vvvv beta and we wanted to add a color, what would we have done? We would have somehow collected, created a separate spread which collects the colors. And so maintain two spreads. The one is the spread of positions and another spread of colors. And then when we draw it, we always have to make sure that the right amount of points is drawn with the right amount of colors. Right? Doable, but already kind of a brain fuck. And here comes the second biggest feature that we introduce with vvvv gamma. It's we can create our own data types. What does that mean? What's a data type? All the things we've been using, the numbers and the strings and the colors, these are called data types. The type of data is a text string, or it's a floating point number, it's a float, or it's an integer number, it's an integer, or it's a color. These are all different types of data, right? They're called data types. Now, the ones I just mentioned are simple, primitive data types. But think of it, there are more complex data types. The simplest of the more complex one that I can come up with is a vector. Right? A vector is a data type with two components. One component for x, which is again a primitive type, a float number, and another component y, which is again a single primitive float data type. So all the complex data types are always made up of more primitive data types, and you can go very complex. So you could think of a more complex data type, which is a particle, which has a property called position, but the position is only a vector, and the vector is only made out of two floats. And the particle could have a color and a label of text, and together the position and the color and the text make up the more complex data type called particle. Okay? So that's just the idea of data types. And in the beta, we were not able to define our own data types. We would always be limited to spreads. We could somehow say, we think the first three numbers in the spread are now the position, the second two numbers are the speed of the particle, and so we could work around things, but it was very hard. And instead, what we want to do is we want to be able to define a data type and say, when we say stroke, let's call our data type stroke, then what we mean is actually the stroke is a complex data type, and it consists of more primitive data types. One is a color, and the other one is a spread of points. So our stroke would be a very simple complex data type consisting of two properties, a spread of points, and the color. Okay? So the question is now, how can we create our own data type? And when we create our own data type, we are defining a data type. So the key word here is we are defining a new data type, and that brings us to something which is only available via the menu here. It's called the definitions. So we're going to see the definitions and define our own data type there. We're clicking and we're landing on this patch, and we see there is already something on this patch. Remember the guy that we created before? The node, my animation that we created before? We didn't think about it as a definition. We didn't think about that we defined a patch that we use an instance of here. But actually, what happened when we created this new node, we automatically created this definition. Good thing we didn't have to think about it. But now it may be slowly dawning what is happening here. Anyway, so this definition patch is where we put our own definitions, and we want to create our own data type. So what we are doing is double click, and a data type, there are different ways you can define a data type. One of them, the simpler one, is we create a record. So we type record. And I press enter, and now I'm...
If I may interrupt, it's not really easy to distinguish the tabs in terms of like data type and patch. It looks just a little icons.
Yes, yeah. So,
can you say one more time how I get there?
Yeah, okay. So I'm doing this all again. I was here, and I'm going to the definitions patch via the menu here. So I'm going to the definitions of this document. And just to show you the duality of definition and application, there is also this menu entry called application. When I press this, I'm here. So this is the application side of things, and this is the definition side of things. And the way we distinguish, as you see, is, yeah, it's very subtle, but here is this little icons with the lines, and here is no lines, no icon with the lines. So that's the difference. And also the background of the patch is different.
Are we going to talk about this whole saving things later? Because now we're just saving, and I'm like, where is it going?
Yeah.
Okay.
No, but I mentioned where it's going.
Yeah, but I don't know. When I was...
Okay. Let me say one thing. You're a bit worried, I assume, because in the beta there were always a lot of things you would save. Like every patch would be a file on this.
Where to find it and how to put it somewhere else.
Yes. And one of the big things here is everything is by default in one document.
Okay.
You don't have to worry about it. You can separate your work, we will see that later, but you don't have to for a start. Often you don't care. Right? So now we wanted to create our own data type, and as I said, we are doing this by creating a record. I press enter and choose a name for the record, and it will be called a stroke. Now, again, to go to the actual patch of the stroke, I can right-click open or middle-click. Now I'm inside of the stroke. This is where I define the properties and later also the functionality, the behavior of the stroke. We'll come to that. But first, let's define its properties. And what were the properties again?
Position, size,
Exactly. In our case, we wanted color. So the way we do this is we just type color and then choose pad, because again, we will be storing the information, the color information in a pad. So this is the first pad, and the second was going to be the points, where I collect the spread of points. So I'm just calling it points, and again choose pad. Now I have these two pads here, but they don't have any more information yet about them. They only have their names. But now I want to tell the system the thing that I call color
Could be anything.
could be anything, but I want to be more specific about it. I know I want it to be a color, and the color type in is called RGBA. Okay, that's the name of the primitive color type. And so to tell the system that this color pad will actually be an RGBA type, what I do is I need to annotate the type. And this works by right-click, configure, or as I like to do it, just middle-click to bring up the configure box. And then in the type browser, I choose RGBA. Press enter. And you see now these two look slightly different. You see there is a black dot here, which means it's annotated. It has a specific information. And here is an empty circle, which means no information about the type yet.
The difference will be bigger though.
Yes.
More color.
Maybe.
You know, these are the things that you just intuitively understand at some point, and then it's in the face all the time, or it's enough information like this. To annotate this point, again, I'm middle clicking, and I choose, in this case, this should be a spread of vector 2. So I have to type this out, and to say it's a spread of something, I'm using these, what are these called? Angular brackets?
Angular.
Yeah. A spread of vector 2. And you have to close brackets, press enter. And now the system understands.
No code completion.
No.
Will be.
And it doesn't matter if you write big or
No, it's important.
caps, uppercase, lowercase.
Sometimes not, and sometimes yes. This needs to
I
be.
see most this time.
Yeah.
Also, the drop down is not black yet.
Yes. Yes.
Is it not?
Okay, so now I told the system these pads have a specific data type. And now, remember I said to introduce you to the idea of complex data types, I mentioned the vector, right? And remember the vector nodes, we have the vector join and split nodes in vvvv. Vector join takes two floats, returns a vector. Vector split takes a vector, returns two floats. Okay, so it's kind of a join and split. So, and that is actually what we usually want from a data type. We want to be able to create it from its components, and then at some point we want to split it out to its components. Okay, that's typically the simplest thing I want from a data type.
And this can get very complex, and you should remember that, because later I'll show a very interesting example on how you can use only this feature to clean up big and messy patches.
So we want, what we want now is two nodes. We want to have the system to create two nodes for us, like one create stroke node and one split stroke node. Okay? And the way we tell the system to do this is we need to create two operations, because each operation will be available as a node. We want to create a create operation and we want to create a split operation. Okay? And for now, I'm just showing you the shortcut without explaining much. Because in this case, in this very simple case, it's enough that we know how the shortcut works. I'm just selecting the two paths and I press Control K. And what this does is it creates what I just said. It creates a create operation with two inputs, and it creates a split operation with two outputs. That's just what happened now. You see, when you hover with the tooltip, it says RGBA add split, and this add split means this output here is part of the split operation, and here we say it's add create. It means it's part of the create operation. Okay. So now, if we go back to our patch and have a look in the node browser, and we're looking for stroke. Did I just forget something?
No. I switched to record now.
Yeah, okay, all good. So if we're looking for stroke, we see there is an entry, and now to answer your question from before, what does it mean, this icon? So it's a different icon than the stroke node. This is a stroke data type. So this icon means it's a data type. We can click it, and inside we see the operation nodes that are now available. And these are exactly the two that I promised would be there, the create and the split. So now we can choose create, and you see what we get is similar to the vector, where we have the x and y component to create the vector, and here we have the color and the spread of vectors that creates us a stroke. So at the bottom we just now have one element to deal with. And here it gets interesting, because now we don't have to think about the spread of points and the spread of colors separately anymore. We can just think of a spread of strokes, right? That's the power of creating your own data types. You can like encapsulate things together and then make it easier for yourself to think about them. Okay? So now that we can build a stroke, the next thing we want to do is to add the stroke to the spread here, to our spread of strokes. So instead of only the points that we collected, we want to add the whole stroke. So I'm disconnecting this, and also for demonstration purposes, I will disconnect this link down here, because this is where the spread of points came out again. Right? So I'm disconnecting this, and you saw what just happened is I'm undoing this. So you see these pads and links and pins, they are now solid. And if I disconnect this one, you see that they all go transparent and hollow. What this means is, and this is the third biggest feature introduced with vvvv gamma, is we're talking about generics here. Meaning this add node and the clear node, they don't care what comes in their input. They are generic. You can feed it with a color, with a string, or a spread of color or whatever. They don't care. They are generic. And this allows us to just keep the patch as it was and now simply connect a stroke here. And boom, the whole patch back to solid again, because now it knows, okay, I'm dealing with a stroke, or a spread of stroke here in this case. Okay. So that's this, and now we want to add the whatever like points we have just collected in the queue is what we want to add to the create our stroke off. So I'm moving the pressing spacebar. I'm moving the create node inside of the if region, and I'm taking the queue output here and connect it to the points input of the create stroke node. And now it leaves us with the situation down here where we get a stroke out. And for each of the strokes that we have in here, what do we want to do?
We want to draw it, but we have to split it up again. Right?
Split. Now is where the split comes in. So I'm just starting a link, double click, split. Second question, which split? The one we just created, the stroke split. We have it here, and this again has the color and the points. Connect the points, and we are back. Only that now we can also add a color. So I will basically say whenever I press, whenever we insert the stroke, we're just choosing a random color. Okay? So for that, I'm using the from HSL node, which just creates a color for us. And to create a random color, I'm using the random node. Here again, you see a demonstration of the genericness of the random node, because it just doesn't know what random what could be a float or an integer, and only by connecting it to an input of the HSL node, we tell it, okay, we want you to create a random float, and the default is anyway between 0 and 1. So now, actually, whenever I press I insert a stroke, it should have color, and it doesn't. And yes, who knows why? Yes. Yeah. So the color is not connected yet. Okay. So the color comes out here, but it's not connected. And what we do with this? How do we get a color? From the fill. So again, we need a fill node here. And connect the color to the fill. And now okay. Ja. Also Das Foto.
Stimmt, kannst du mal hin.
Ah, nicht komisch. Ist das alles? Und gleich? Passt.
Also 130.
Ja. Then maybe something is still connected down here, but can you disconnect from the...
I'm back in a sec.
Yeah? Okay, so... Yeah. Yeah. This is not. That's missed out. That's okay. Case sensitive. Okay. But does that work so far?
Yeah.
So we have now half an hour left, and we will easily finish this. And there was a bit more planned, but yeah, maybe let's just continue with this. So remember from the example, what's still missing is the part where these shapes now get smaller and get removed. Because at the moment, as I make more shapes, they just fill up and they will never leave, right? So if you see here, the count will always grow. And at some point, we want to define a behavior where the strokes, the shapes get removed. And so I thought, let's just fade them out by making them smaller. And when they're small, then they're gone. And so this is something that's kind of a property, again, a feature, a behavior of the stroke, right? That the stroke, once it has been created, it would start shrinking. And once it has shrunk to 0, then it would go away. So in order to define some behavior for the stroke, we just, again, go back to the definition of this stroke data type. And it is here where we define this behavior. And the way this works is we say in every frame they should shrink a little. And the way to define the shrinking is we want to have all the points of the contour move towards the center, okay? So how do we get the center? We take the average of all the points, and that is the center. Like in math, if you take the average of the points, you get the center point. Okay. So let's start with that average. Now we have the center point, and what we want to do is each